So in the lecture classes, we introduced the concept of sigma algebra and measure space. Those are the primitive concepts to develop the theory of measures and integration. And if you recall, those abstract notions, sigma algebra and measure space, were motivated by our own experience with measuring standard objects in R1, R2, R3, and so on, like length measure, area measure, and volume measure. So two things were involved. One is a collection of subsets, and another one was a function. And the requirement on collection of subsets and requirement on the function go hand in hand. And we have imposed certain conditions on collection of subsets in order to form sigma algebra. Intuitively, sigma algebra should be closed under all possible set operations. Union, intersection, complementation, set difference, and so on, with countable number of elements in it. To be precise, a sigma algebra is a collection of subsets of a set having the following properties. If A is in that sigma algebra, or the collection which you want to call as sigma algebra, then a complement should be there, null set should be there. If ANs are elements in those collection, then union AN should also be there. To put in simple language, a sigma algebra is a collection of subsets of a set X which is closed under complementation and arbitrary, countable unions, not arbitrary union, countable unions. Okay. And now look at the definition that I have given in the tutorial sheet. I have defined what an algebra is. The word sigma is missing, so the countability will be missing. Otherwise, it is same as sigma algebra. To be precise, a collection A of subset of a set X is called an algebra. And A satisfies the following condition. X is in A. 2. If A is in A, then a complement is in A. So these are requirements same as sigma algebra. So what makes algebra different from sigma algebra is the third condition. For an algebra, we just demand A and B are in A implies A union B is in A. Whenever you have two elements in that collection, obviously elements will be sets. Their union also should be in that collection. Okay. Obviously, from third, you can prove that script A is closed under finite unions. In fact, A is closed under finite union. That's obvious by induction, right? If A1, A2, A3 and so on, AN for a finite n are elements in A, then union AA is also an element in A. So what's the difference? Chief difference between an algebra and sigma algebra is in the third property. Algebra is closed only under finite union, whereas sigma algebra is closed under countable unions. Okay. Obviously, every sigma algebra is an algebra. And the converse need not be true. You can easily construct examples of algebra which is not sigma algebra. In fact, the third problem gives you one concrete example. So we will not spend time on it. When we come to third example, third problem, you will get a concrete example of an algebra which is not a sigma algebra. Okay. Now, coming to the first problem, this is the definition of algebra. Now, what problem demands you to do is you are provided with a collection satisfying two conditions, and you have to prove that that collection is an algebra. And what are the two conditions given? Full set is in the collection. Whenever you have two sets, their set difference A minus B is also in the collection. If the collection satisfies these two conditions, you have to prove that it is an algebra. Okay. Did you try? Somebody have tried means you can tell how to proceed. It's not that hard. For an algebra, you need three conditions, which I have listed here, but you have supplied with only two conditions. Okay. So let me first start. Let A be a collection of subsets of X. Sorry, subsets of X satisfying two conditions. X is in A, or you can say null set is in A. And I mean, in the definition of algebra or sigma algebra. And if A and B are in A, that implies the difference A minus B is in A. And what is demanded? To show that A is an algebra. This question is nothing connected with measure theory. It is just set theory. So to prove that it is an algebra, you have to prove these three conditions. First condition is explicitly given, X element of A. This is given condition. And second, starting with A in A, I have to prove that A complement is in A. Naturally, I have to use the second condition given. If A and B are in A minus B is in A. So somehow using that, I have to get A complement is in A. Yes. What should I do?
So we take X and A belongs to A, then
Yes.
X minus A equals to A complement.
Yeah. So it's just definition. The complement is difference of the set with the universal set X, right? We know that A complement is X minus A. This is the definition of A complement. And also we know that X is in A from 1. And you have started with A is in A. Therefore, A complement is in A. By the second condition, whenever you have two sets, the difference is in A is the second condition. So the second condition required for algebra follows from second condition given in the problem. Now third condition required for an algebra. So I have to take two elements in A. Let A and B are in A. Somehow I have to prove that union is in A to show that A union B is in A. See the previous one. If A is in A, we could prove that A complement is in A. Right? Whenever A is in A, we could prove that A complement is in A. Okay. So with that in mind, somehow I have to write A union B in terms of complements, right? And for that, I have to use De Morgan's law. I have to invoke De Morgan's law. So first, A union B complement, or A union B is A union B complement. That is A complement intersection B complement by De Morgan's law, complement. So if I can prove that A complement intersection B complement is in A, I am done. Right? For that, what I do is, suppose A and B are in A. Can I prove somehow A intersection B is in A? Suppose A comma B are in A. Can I prove A intersection B is in A using the given condition?
Yes, sir.
Yeah. So for that, I have to write it as a difference because given condition is in terms of difference, right? So I can write A intersection B as, how do I write it as a difference? A difference B complement. Do you agree? That follows directly from the Venn diagram if you want. Otherwise, you can prove it. A intersection B is A minus B complement. When A is in A, B is in A is in A, and B complement is in A. And this is in A because A is in A and B complement is in A. Whenever B is in A, we already proved B complement is in A. So, whenever you pick two sets in A, their intersection is in A. So, A complement intersection B complement is in A. Therefore, A comma B element in A implies A complement and B complement are in A, and that implies A complement intersection B complement is in A, and that implies A complement intersection B complement, the whole complement is in A. All these are set theory, and that will imply that A union B is in A, and we are done. Okay, so this is the hint. I have to write A union B in terms of complements and intersections. Okay. With that in mind, we proceeded and could prove that whenever A and B are in A union B is in A. So we are done. I think that's the first question. If you wanted to prove some, yes.
तो ये जो थर्ड पार्ट है इसे ऐसे प्रूव कर सकते हैं क्या मींस x माइनस a इज इन a देन जो हमारा ये x माइनस a आया इसमें से माइनस कर दें b.
I'm not able to hear you properly, first of all. If somebody can make her question and pose it properly, it will be nice. I am not able to hear her properly. What is your doubt? Please proceed.
So she is saying कि, we take x minus a belongs to a and then minus b in this way.
See, there may be several alternative ways. So if at all you are interested to proceed a question with an alternative way and see whether it is correct, please don't pause in between when I am doing it. You can write it through an email, say that this is my approach, and then ask me whether it is correct or not. A problem can be approached by several ways. There is no unique way to solve a problem. Okay, so obviously if 60 students are there and they are coming with 60 different approaches, maybe they are all connected, but still there may be, apparently they are all different. I cannot answer each 60 and say that yes, this is also correct, this is wrong, and so on. Okay, this is one approach. There may be definitely some slightly alternative approaches available, and if your interest is to see whether your approach is correct or not, you should solve the problem and send it to me and ask whether this is okay or not. Okay. I think I have answered. But you should understand the situation. If 20 are attending and 20 are coming with the 20 different approaches and asking me whether this is correct and so on. Of course, it is good. You should have your own approach to solve a problem. However, I cannot answer all these things at that time. Then I can solve only one problem in a tutorial class. Okay. So this is one approach. If you are okay with it, take it. And if you have an alternative, please let me know. I am also interested to know. But that not in the class, but through an email or whatever it is, so that it will save some time. Okay. So having said that, let me go to the second problem. So first one is just set theoretical, I would say. Second one is you are given with an increasing sequence of algebras of a fixed set X. You have to prove that the union is again an algebra. Okay. So let sequence n belong to n is an increasing sequence of algebras. You should decipher the word increasing. Increasing means A1, so it is script A. A1 is contained in A2 is contained in and so on. Okay, and A1, A2, A3 all are algebra of subsets of a set X. The parent set is same and you are defining many algebras on that parent set X and they are A1, A2, A3 and so on. Further, ANs are increasing. You are supposed to prove that union AN is an algebra. To prove that union script AN, n belong to n, is an algebra. To prove something is an algebra, you have to see these three conditions. That set collection should be closed under complementation. That collection should be closed under finite union or union of two sets, and full set should be in A. Okay. So let me put a notation. Union AN I will call as script A, and I have to prove that script A is an algebra. So let us see the first condition. I want to see whether X is in A. That is obvious, right? Yes or no?
Yes, sir.
How does it follow?
N are algebra, so N.
Each AN is an algebra. So in fact, each AN contains X. Okay. Therefore, definitely X will be in A. X belongs to AN for every n. Actually, for every n is not needed to say that it is there in the union. But here it happens. And that definitely implies X is in A. This should not mislead you. To say X is in A, it is not necessary to say X is in AN for all n. But here it happens as AN is an algebra. Okay. So that obviously gives condition 1. Condition 2, if A is in A, I have to prove that A is in A complement. Sorry, A complement is in A. So let me see, fix some A, capital A, in script A. I have to prove A complement is in script A. This implies A is in union AN. That's the definition of A. Script AN. That will imply A is in AM for some M.
Some
Yeah. But AM is an algebra. That implies A complement is in AM. Because AM is an algebra. In fact, you can say one more thing. If A is in AM for some M, then A will be in script AN for all n greater than or equal to M because of increasing nature. But that is not needed here. Anyway, so A complement is in AM, and that will imply that once it is in 1 AM, it will be there in the union. A complement is in union AN, n belong to N. And that's by definition is our script A. A complement is in script A. So A in A provided us a complement in A. So second condition is satisfied. Now third one. Okay. That may be the only thing which is slightly non-trivial. Okay. Let two elements I pick from A. Okay. That means is A and B are in union AN, script AN, n belong to N. Okay. Now, can you say how to proceed? So, of course, this will give A is in some
AM.
AI.
Can I say that that implies A and B are in A n naught for some n naught in N?
Yes, sir.
Yes, sir.
Yes, sir.
And that will imply A union B is in A n naught. Because A n naught is algebra. Okay. And that implies A union B is in union n element of N AN. You should be convinced with this. This is the only step. If A, B are in union AN, how do you say A and B are in AN naught for some N naught? Okay. Once you are convinced with that, rest follows automatically. And that implies A union B is in A. So whenever you pick two elements in script A, their union is in A. Therefore, A is closed under union of two sets, and hence union of finite number of sets. Those who are not speaking, please mute. I can do that, mute all. Yeah. Therefore, A is an algebra. So if you have a monotonically increasing sequence of algebras on a fixed set X, their union is also an algebra. And second part is interesting. Whether a similar result hold for an increasing sequence of sigma algebra. So you have an increasing sequence of sigma algebra, and the question is whether union will be again a sigma algebra. Question is, if script AN, n belong to N, is an increasing sequence of sigma algebras, is it necessary that union AN, script AN, is a sigma algebra? When I say sigma algebras, they are all sigma algebras of same set X. Okay. What do you feel? And where did you use this algebra nature, but not sigma algebra? If you see the proof, then you should get a hint to construct a counterexample. So I would say that you have to construct a counterexample because it is not necessary that union is a sigma algebra. Could somebody get? Again, it is some way connected with the third problem, because third problem asks you to get an algebra which is not a sigma algebra. Part B says it is a sigma algebra if and only if X is a finite set. Okay. So I will give, to answer this question, I will give a counterexample here, but it will be more clear when we do the third problem. Okay. So let me give a counterexample just for the sake of completion. I will put the counterexample here itself. Okay. But this is based on our third problem. I take X to be the natural number system N. Okay. Now on this X, I have to construct a family of sigma algebras, which are increasing. So the sigma algebras are AN is equal to the family of all subsets of the first segment 1, 2, 3, etc. up to N and their complements. Let me write a few ANs. A1 would be the collection. You take all subsets of 1, set 1, which are null set 1, and their complements. Okay. What are the complements of null set? It is N, and complement of 1, N minus 1. So this is your A1. Okay. And A2 is all subsets of set 1, 2, which is null set 1, 1, 2, and their complements. That means N, N minus 1, and N minus 1, 2, and so on. And A3 would be all subsets of 1, 2, 3 along with their complements. Okay. Then you see that AN is a sigma algebra for each N. Okay. And you can very easily see that it is monotonic in nature. A1 contains, A2 contains, and so on. Okay. Now, what is union AN? Can somebody say what is union AN? Look at AN. AN is family of all
N, sir.
subsets of 1, 2, 3,
N.
etc. Yes. Can somebody tell me what is union AN?
N, sir.
N.
See, union AN, how can it be N? It will be subsets of N, right? A1 contains subsets of N, A2 contains subsets of N. So union AN would be a collection of subsets of N. Do you
All
mean to
finite
say that it
subsets.
will be only N?
Power set.
All finite subsets of n and their complements.
Finite subset
No,
and
it
their
is not power
complements.
set of N. UN
The
is
finite subset.
all finite sets will come, right? Because A1 contains sets with one element subsets. A2 contains subsets with 2 elements. A3 will contain subsets with 3 elements and so on. So union will definitely contain all finite subsets. Okay. So is the family of all finite, not over. Okay, definitely all finite subsets will be there. And what about the, see, A1 contains n minus 1. A2 contains n minus 1 and n minus 1, 2. A3 will contain n minus 1, n minus 1, 2, n minus 1, 3, and so on. Okay. So what will be union will contain? All these things will be there. And there is a terminology called cofinite subset. And the meaning is that its complement is finite. Okay. So union AN is the family of all finite and cofinite subsets of N. Do you agree? Yes or no?
Yes, sir.
Cofinite is defined in problem number 3. Okay. Cofinite means a set is called cofinite if its complement is finite. You might have heard this in topology. Similarly, a set is called co-countable if its complement is countable, and so on. So union of all this sigma algebra is family of all finite and cofinite subsets of N. But I claim that this union is not a sigma algebra. That's what we are going to do in third problem. But union N belong to N, script AN is not a sigma algebra. That we are going to prove in third problem. Okay. So you have got a monotonic sequence of sigma algebra whose union is not a sigma algebra. To see that each AN is a sigma algebra is straightforward. And how do you see that their union is not a sigma algebra? That we will be doing now. Okay, so let us take third problem. So to consolidate a monotonic sequence of algebra, if you have, their union will be again an algebra, but same result doesn't hold for sigma algebra. Okay. So far, so good. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
So let us go for third problem. X be an arbitrary infinite set. In fact, I could have written arbitrary set. Nothing will happen. It need not be infinite, but anyway. So that means it can be finite, countably infinite, or uncountable. But in the problem, the finite case is avoided. But now I am saying even finite case could have been included there. Okay. So you can read it as let X be an arbitrary, let us take non-empty set. We say that subset capital A of X is cofinite if it complement A complement is finite subset of X. So there is a typo. That should not be a script A, it should be just A. A subset usually of X is cofinite if its complement A complement is finite. Is a finite subset of X. So there is a typo, I repeat. It should not be script A, this is A. Okay. Instead of script A in given sheet. Okay. So this I have already defined in previously. Now A consists of all the finite and cofinite subset of X. Now comes script A. Script A is equal to set of all A subset of X. A is finite or A is cofinite, meaning A complement is finite. So this is your script A. And you are asked to prove that A is an algebra of subsets of X. Okay. By the way, before going to that, I told you that you can read it as X be an arbitrary set. It can be finite also. Suppose X is finite, what can you say about script A?
Power set of
Suppose X is
Power set. Power set.
power set. That's why I wanted to exclude it. Power set is a algebra, or in fact it is a sigma algebra, is known to us, right? So let me just note down that if X is a finite set, then script A is equal to 2 power X, the power set, which is in fact a sigma algebra and hence an algebra. Nothing to prove. That's why we took only infinite sets. Okay. Now suppose X is an infinite set. Suppose X is an infinite set. We want to prove that script A is an algebra. Okay. To prove that script A is an algebra. Mostly first two axiom would be trivial. First axiom is to see that full set X is in A. Do you see it? Full
Yes.
set X is in A.
Yes,
Yes,
sir.
sir.
Yes, sir.
How does it follow?
Its complement is finite.
Yes.
Five,
For a
five, five.
set to be in A, either it should be finite or its complement should be finite. Okay. Now, if you take X, X can be written as X minus null set. And you know that null set is finite. Okay. Null set is finite. Therefore, X is cofinite. A set is cofinite if complement is finite. So X is cofinite and therefore X is in A. Second. For second, what I should do? If A is in A, I have to prove that A complement is in A. Okay. So let us start with let A is in A. By the immediate definition of script A, you can say that A will be either finite or cofinite. Then A is finite or A is cofinite. That is X minus A is finite. Now, do you see that A complement will be in A?
Yes, sir.
If
Yes, sir.
if A is finite, A complement is cofinite by the
Cofinite.
very definition, right? If A is finite, though it is trivial, let me write it for the sake of completion. If A is finite, A complement is cofinite. Something is cofinite means its complement is finite, right? So A complement is cofinite. And once A complement is cofinite, A complement will be in A, and that implies A complement is in A. Now, if A is cofinite, only two possibilities there. A is in A means either A will be finite or A will be cofinite. Finite case settled. Now let us take cofinite. If A is cofinite, then by the very definition, then A complement is finite. And A complement is finite, then A complement will be in A. So in both possibilities of A, you get A complement is in script A. Okay. Thus, A in A implies A complement is in script A. That means script A is closed under complementation. That is the requirement 2. Requirement 3 for an algebra is script A should be closed under unions, finite union. Okay. It is enough to prove for union of two sets. Suppose, let me start with two candidates, A and B in A. Somehow I have to reach at the conclusion that A union B is in A. What are all the possibilities? A and B are finite is one possibility. Okay. If A and B are in A may be finite or A may be cofinite, B may be finite, B may be cofinite. So there are several possibilities. First, let us work A and B are finite. If A and B are finite, A union B is finite. And once a subset is finite, it will be in the script A. Therefore, A union B is in script A. We are done. Now, what is the other possibility? One is finite and one is cofinite. Okay. Assume A is cofinite and B is finite. In that case, since A is cofinite, A complement or X minus A is finite. Okay. Here, X minus A is finite and B is finite. What is your target? Your target is to prove that A union B is in script A. For that, you have to prove A union B is finite or A union B is cofinite. Now, do you agree this? X minus A union B is contained in X minus A.
Yes, sir.
Correct.
Yes, sir.
Because A containing A union B.
Yeah. But this is finite. Therefore, subset should be finite. Therefore, X minus A union B is finite. Once a complement is finite, the set is called cofinite and set will be put inside script A. And therefore, by definition, A union B is cofinite and you are forming script A by picking finite and cofinite subset. Script A union B is in script A. That implies A union B is in script A. Okay. So if A and B are in A and A is cofinite and B is finite, then A union B is in A. Now again, two more possibilities there. One is very similar to this. Suppose B is cofinite and A is finite. Similarly, you can prove. So only one thing what is missing is if both A and B are cofinite. Again, the same thing will work. Yes or no? If you see here, I have not used finiteness of B. Irrespective of whether B is finite or not, once A is cofinite, I could prove that A union B is in A. Am I right?
Yes, sir.
Yes, sir.
So all other two cases are also can be similarly dealt with. Let me write. Other cases can be similarly dealt with. See, I should say that in tutorial, I expect more involvement. Okay. So please try to answer the questions. Please feel free to say your points, but not an alternative method. Please do that. Other cases can be similarly dealt with. Therefore, what did you prove? A comma B in A implies the union A union B is in A. So A satisfy all the three conditions. Therefore, A is an algebra. What was A? Collection of finite and cofinite subset of an infinite set. Now the B part. Suppose I want this A to be not just algebra, I want it to be a sigma algebra. Okay, that is possible only when X is a finite set. This finite and cofinite subset, if you collect and put inside the basket script A, the basket will be an algebra, but it will not be a sigma algebra in general. It can be sigma algebra only when the ambient set that you are taking is a finite set. Okay, so let me go to the B part. To prove that, script A is an algebra, sigma algebra. Definition of script A is same, okay? Finite and cofinite subsets of X. If and only if X is a finite set. One part is obvious. Which part is obvious?
Only if.
X is a finite set will imply A is a sigma algebra. That we already wrote. But let me write again. If X is a finite set, then script A will be equal to 2 power X. Therefore, script A is a sigma. There is nothing to prove. 2 power X is closed under every set operations. Okay. Now the converse. If A is a sigma algebra, then X ought to be a finite set. Okay. So let's just assume the other way around. Suppose X is infinite. So what you have to prove? Suppose A is a sigma algebra. We have to prove X is finite. Assume for a moment that X is infinite. Assume, so I am going by contradiction. For a moment that X is infinite, maybe countable, maybe uncountable. Okay. What I want to get a contradiction is that then A cannot be a sigma algebra. That means one of the conditions required for a sigma algebra will be violated. And which condition do you expect to be violated? There are 3 conditions for sigma algebra. The first 2 will be true. So only condition that you can expect to be violated is the third one. That is, script A is not closed under arbitrary union. Countable union. I should not say arbitrary. Many times I'm saying arbitrary. Please read it as countable. Okay. So I have to prove that script A is not countably closed under countable union. Script A is not closed under countable union. Okay. So for that, what I have to do? I have to find a countable collection of elements in A whose union is not in A. That means whose union is neither finite nor cofinite. That means whose union is neither finite, whose complement is also not finite. So whose union should be infinite, complement also should be infinite. Like that, I have to find a sequence of sets in A. Okay. Is it clear?
Yes, sir.
So how
Yes,
do
sir.
you do that? So now if it is clear, you should be able to tell how to proceed. So what I am looking for? I am looking for a sequence AN, script AN, such that union AN is neither finite, whose complement is also not finite. So union also should be infinite, complement also should be infinite. Okay. Remember, we are working with an infinite set. X is an infinite set. If X is an infinite set, can we get an infinite sequence from it, distinct?
Yes, sir.
Yes. If it is countable, X itself will be an infinite set. If X is uncountable, then you can extract a countable subset, which is a sequence. Countable means you can list. Okay. So since X is infinite, we can find an infinite sequence A1, A2, A3, etc. of distinct elements of F, X, distinct elements of X. No, not over. I am going to put some more conditions such that you should say whether it is possible or not. Such that X minus A1, A2, etc. is also infinite. Do you agree with this statement?
Yes, sir.
Yes, sir.
Maybe those who are thinking X as countably infinite and X itself has A1, A2, A3, etc. may find a issue with this. But I am not saying every infinite sequence. I am just saying you can find an infinite sequence A1, A2, A3, etc. such that X minus A1, A2, etc. is also infinite. For an uncountable case, it is obvious. For a countable case, suppose X itself is A1, A2, A3, etc. This A1, A2, A3 that I have to start with should be a subsequence of it. Are you able to get me?
Yes, sir.
If X itself is A1, A2, A3 and so on, the A1, A2, A3, etc. here I should take should not be whole X, but it should be an infinite subsequence. So that again, I can have the difference and it will be again infinite. Okay. Anyway, this is always possible. Now, what I will do is, my aim is to get a sequence of algebras. Okay. No, sequence of elements. What am I trying to do? Sequence of countable elements, countable number of elements in script A whose union is not in A. That's what I have to prove. Show that A is a sigma algebra if and only if X is a finite set. Sorry, in between I lost track. So I am going to write AN as set AN. Okay. Then each AN is finite and therefore AN is in script A for all N. For all N. Now consider union AN. Union AN. I would say that it is not in A. However, union AN is not in A. Do you agree or not?
Yes, sir.
Right? If you want
Because
union
of
AN to
our
be
choice.
A, either union AN should be finite or it should be cofinite. But see the way in which we took ANs. A1, A2, A3, etc. AN is not it's not finite and its complement is also not finite. It is infinite. Okay. So I will just write union AN is not in A. Okay. Therefore, script A is not a sigma algebra. You could find elements in script A whose union is not in A. Therefore, A is not a sigma algebra. This is a contradiction. You started with a sigma algebra, okay, which is a contradiction. Why this contradiction? Because what is the source of this contradiction? You assumed that X is infinite. Therefore,
Finite.
X is finite. Therefore, X is finite. So the collection of finite and cofinite subset will always form a algebra. But if you want it to be a sigma algebra, the parent set X should be a finite set. Otherwise, it is not possible. Now go back to the second problem where I have given an example. Union AN is not a sigma algebra, I wrote. What is union AN? It is family of finite and cofinite subset of N. N is infinite. For an infinite set, if you collect the family of all finite and cofinite subset, it cannot be a sigma algebra, is what we proved in 3. That's why the last statement holds. But union AN is not a sigma algebra holds because of third problems. I would write here, see the next problem. Are you with me? Do you follow?
Yes, sir. Yes.
So finite and cofinite subset you collect inside something and call it as a script A. Then that script A will be sigma algebra. I'm sorry, an algebra irrespective of whether X is finite or infinite countable or infinite uncountable. But it will be a sigma algebra only when X is finite. So let me stop with the next problem. At least I will start so that you can proceed with it. You are given with a set function defined on a sigma algebra. So mu is defined on B to somewhere, I don't know. So let us take it as to be R
We have
union.
class.
Yes. Tell me. You have a class. Okay.
Yes,
So I
sir.
will stop here. I will stop here. I wanted to give the definition of additive and countably subadditive. It's okay. So let me stop recording and leave the meeting. Thank you.
Thank you, sir.